Okay. Today we shall be developing. Today we shall be developing EGARCH model. So that is our plan. We shall be developing EGARCH model. So in other words, our topic is leverage in the EGARCH model. So that is our topics. That means our topic is the leverage in the EGARCH model. So meaning that this one actually is the leverage model that we shall be developing today. Okay, leverage model that we shall be developing today. And here we have the data BSR, right? The BSR, here is the data. What is BSR? That is Bangladesh stock return. That is called BSR. And the sample size for this one is how much? How many? 200. You can see the sample size 200, and the variable is BSR. That is Bangladesh stock return. And also we have another variable, that is C. What is C? C means constant, or that is constant of the model. Okay, now the question is should we run ARCH model or EGARCH model, right? That is the question. Now the question is, should we run ARCH model or EGARCH model? And here EGARCH actually is the family member of ARCH model. Here EGARCH actually is the family of the ARCH model. Okay, now the thing is, when we should run ARCH model, there should be a guideline to run ARCH model. Okay, so what is the guideline? Okay, what is the guideline? Okay, the guideline number 1. The guideline number 1. What is the guideline number 1? First we run the regression model such as BSR is the dependent variable and C. What is C? Constant. And here there is no other independent variable, only these two, BSR and C. Okay. So what we do, so I go to quick estimate equation, and here I put BSR and C, right? BSR and C, and here BSR is the dependent variable. What is BSR? Bangladesh stock return, and C is the constant, and here is no independent variable. So here I can run the model. So I click on the OK. So this is my model that has been estimated. Okay, that has been estimated, my model. And from this model, so this is the dependent variable BSR. Okay, now from this model I check the residual. So here you can see residual of this model. I click on the residual. Okay, and you can see that is the residuals, right? And here actually the data from day 1, it is the day 1 until day 200. So actually we have our sample size is 200 days return. Actually our sample size is the 200 days return that I am writing here. Our sample is 200 days return of Bangladesh stock, right? Return, right? 200 days. That is BSR, right? 200 days of Bangladesh stock return. What is stock here? Stock means equity. Here stock means equity return. Stock means equity, right? Equity return. Stock means here equity return. Okay, this is important. Stock means equity return. 200 days. So it is the day 1, this point, and this point is the day 2. And all these things are what? These are the residuals, right? These are the residuals. Okay. So now from day 1 until day 40, around day 40, so here the fluctuation is very small, right? That means volatility of the residual is very small, right? Meaning that period of low volatility is followed by another period of low volatility for a prolonged period, meaning that 40 days continuously. Okay, here actually I can write the story that from day 1, right, day 1 to day 40, you can say, such as day 1 to day 40, about day 40, we can see that period of low volatility is followed by period of low volatility for prolonged period. Okay, Again, you can see from here, suppose from here, day 40 until you can say day 75, right? From day 40 until day 75, from day 40 until day 75, what is happening here? Here is period of high volatility is followed by period of high volatility. So that means one high volatility has been caused by another high volatility for a prolonged period. Okay, again you see from here 75 day, from 75 day until 150 day, right? From 75 day until 150 day, right? Here the period of small volatility is followed by another period of low volatility for a prolonged period, right? And again you can see from 150, from here 150 to 200, right? From here to here 150 to 200, the period of high volatility has been followed by period of high volatility. So actually what we have seen, from day 1 until here, period of low volatility is followed by period of low volatility, and again from here until here, period of high volatility is followed by period of another high volatility. Again from here to here, right? From here to here, the period of low volatility has been followed by another period of low volatility. So here the period of low volatility has been followed by another period of low volatility, and from here to here, right, you can see period of high volatility has been followed by another period of high volatility for a prolonged period. So when this thing happen, we have the justification to use EGARCH model. When this thing happen, in residual distribution, then we have the justification to run EGARCH model or EGARCH model. Okay, this whole thing we can check in other way. This thing we can check using EGARCH test whether we should run EGARCH model or not. Okay, so we can do the EGARCH test now. So where is the EGARCH test? I go to View, Residual Diagnostic, then you can see Heteroscedasticity Test, right? I click here, and from here you can see EGARCH, right? You choose the EGARCH, then click OK. So this is the EGARCH test and the result, and here is the observed R square and a corresponding p-value. How much is the p-value? The p-value is this one. P-value is here 0.0019, meaning that 0.19%, right? Okay, that is the p-value. And what is the null hypothesis? The null hypothesis of null hypothesis is there is no arch effect, right? And what is alternative? Alternative hypothesis is there is arch effect. Okay, and here you can see our p-value is very small, less than 5%. So we can easily reject null hypothesis and can accept alternative hypothesis, meaning that there is a arch effect. So our model has a arch effect. So we can easily run arch model. We can easily run arch model, and that we shall be doing now. Okay, so actually there are two conditions. Number one condition actually this one that I said previously. Number one condition that when the period of low volatility is followed by period of low volatility, and when the period of high volatility is followed by the period of high volatility, then we should run the arch model. So that is number one, and that we have got it already. And the second condition is, second one is, if there is a arch effect in the residual, then we should run the arch model. And here we have seen that we have arch effect, so we should run arch model. And EGARCH model, actually EGARCH model is a family of arch model. Okay, so now we can run the EGARCH model. Okay, the question is that how to run the EGARCH model. How to run? I go to option, right? Sorry, I go to quick. Okay, and also I can do from here. Here I can click estimate. I can see estimate. I click here, estimate, Then I can put BSR, our dependent variable and constant, right? C. And method, I choose suppose arch, right? Arch method. So, and here there is no other independent variable, right? So only BSR and C. There is no other independent variable, only BSR and C. But if you want, yeah, we can add more independent variable, but we do not want to do here. We have no plan. And from here, I choose the EGARCH, right? I choose the EGARCH. And here is what is happening here. In this EGARCH model, there is a ARCH1 and GARCH1, and the order is 1. And from this model, so the whole thing, this one is called mean equation, and this one is called variance equation. So meaning that it has two parts. One is mean equation and one is variance equation. And what is happening, actually the residual from the mean equation has been used in the variance equation. So that is the thing happening here. I am saying here the residual derived from mean equation has been used in the variance equation to estimate the variance equation. That means I am saying again, that is okay. And here suppose there is no variance things, right? There is no variance variable. So I keep it blank. And here I choose suppose normal distribution. Then what happens? Because here are so many distribution, normal, student, right? But I choose only normal distribution to check. Okay, everything is set now, right? Everything is set. Then I proceed with this model. I click OK. So this is my result, right? This is my outcome. This is the EGARCH model. This is the EGARCH model, right? Okay, so this is our EGARCH model that we have seen, right? This is the EGARCH model. This is the EGARCH estimation, right? That we have seen. Oh, sorry. I'm sorry. We have shifted. Okay, no, sorry, not the EGARCH model. Where is my estimations? Okay, sorry, not this one. Where is the EGARCH model? Just 1 minute. I click somewhere. Okay, so I've done it. Okay, yeah. So it is the EGARCH model that you can see, right? EGARCH model. And here, this one is the dependent variable, log GARCH, right? The GARCH has been transferred into log, and there are and this one is the variance equation. The whole thing from here to here, actually the variance equation. Okay, actually this model has two parts. As I said, number one part is mean equation, as I said. So, and here you can see, from here you can see, this one is the mean equation, the first part of the model, mean equation, right? and here the BSR is the dependent variable. This BSR is the dependent variable, so that is mean equation. And the residual derived from this mean equation has been used in the variance equation. You can see the variance equation, it is here, right? That is variance equation, right? So it is the variance equation, the whole thing. So that means EGARCH model has two parts. One is mean equation and one is variance equation. And that actually the variance equation is here, this one. This one is the variance equation, and here you can see C2 means this one, C3 means this one, C4 means this one, and C5 means this one, right? So there are 4 coefficients to be measured. Number 1 coefficient is C2, C3, C4, C5. Okay, and what is our target? Our target is that to find out the leverage effect. Our target actually is to find out the leverage effect, right? That is our target. And what is called leverage effect? What is called leverage effect? Okay, that we shall discuss now. We shall discuss now what is leverage effect. Okay, but the thing is that when there is a leverage effect is found when you check from here C4, when the coefficient C4 is significant and negative, then we can say that there is a leverage effect, right? Okay, so leverage effect is found when C4 is significant and negative. Then we can say there is a leverage effect. So the thing is that which one is the C4? C4 is here. You can see the coefficient of all these things from here to here. That is C4, right? That is C4, meaning that this one, that is C4. You can see from here. That is C4. And this C4 is the sign is negative. You can see the sign is negative, and also the p-value is very small, meaning that it is also significant. So C4 is having negative sign, and it is also significant, meaning that there is a leverage effect, right? There is a leverage effect. And if there is a leverage effect, what happens, and if there is a leverage effect, then what happens? Okay, then what happens? Okay, so first I talk about what is leverage effect. Okay, what is leverage effect? Okay, so in this model, what is happening? There is a leverage effect. Okay, there is a leverage effect. Okay, what is leverage effect? It means that leverage effect corresponds and actually the leverage effect is a negative correlation between the past return and future volatility of return. So that is the definition of leverage effect, meaning that negative correlation between the past return and future volatility of return. So meaning that, so actually what is this log GARCH? The log GARCH actually is called the volatility, right, of return. This log GARCH is called actually volatility of the return, or this one also called conditional variance, right? So here so there is always a negative correlation between the past return and future volatility of return, and that is called leverage effect. That means when the return goes down, then volatility goes up. Okay. Okay, in other way, leverage effect is a ratio of debt and equity, that is stock equity. Okay, leverage effect is a ratio of debt and equity. Higher the leverage effect, meaning that greater the risk or volatility or variance of a firm. Okay. Okay. Actually, you can see from here, this log GARCH, actually the volatility of the return, right? This log GARCH actually also called the volatility of the Bangladesh stock return. Okay. Okay, then what is happening here? The higher the what is happening here? The higher leverage occurs, the the higher leverage occurs due to negative return, which negative return which translates to a low equity prices, right? Which translate to a low equity price or prices, meaning that a higher debt to equity ratio, and that is called leverage. That is called leverage effect. That is called leverage effect. Leverage effect of a firm. Okay, of a firm. Okay. Okay. So and here in our case, as the C4 is negative and significant, meaning that there is a leverage effect. Okay, and also what does mean by leverage effect? It has some more explanation. It means that where a positive shock has less effect on the conditional variance, So here our conditional variance, actually this one is the conditional variance. That is the dependent variable, that is called conditional variance. And here, okay, so where a positive shock has less effect on the conditional variance compared to a negative news. Okay, what does mean by compared to a negative shock? Compared to a negative shock, news or shock, and it is known as leverage effect, right? It is known as a leverage effect. And here what is happening here, and here conditional variance is the dependent variable, that is log EGARCH, and also which is the variance of the residual, which is the variance of the residuals derived from the mean equation, Okay, so we can say other way that what is called leverage effect when there is a positive shock has less effect on the conditional variance compared to a negative news or shock, it is known as leverage effect. Okay. Okay, then okay, and in other way we can see that, which means that which means that that good news or shock or good news or shock or error, right? Good news, shock, error generates less variance or volatility, less volatile variance than bad news. Okay, than bad news. And what is called bad news here? That is economic condition such as unemployment, and we can call it also inflation, etc., etc. Those are bad news for Bangladesh stock return, that is BSR, right? And here actually what is happening here, okay, which means that I can write from here, which means that good news or shock or error generates less variance or volatility than bad news. Bad news means what? Economic conditions such as unemployment, inflation for Bangladesh stock return. Meaning that when there is a bad news or shock, bad shock or bad information, then volatility of the Bangladesh stock return goes up, right? Goes up. Then good news. So actually that is called leverage effect. And when there is a volatility, and when there is a volatility in return, then in return, especially in BSR, meaning that Bangladesh stock return, then risk of the business goes up. Risk of the business goes up, meaning that investors shift their fund to less risky investment. So that is the leverage effect. And in our model, there is a leverage effect, meaning that bad news can impact on the volatility of Bangladesh stock return than the good news. That means bad news has more impact on the volatility of the Bangladesh bond return than the good news. So our model has a leverage effect. Okay, so here we have already seen that our model has a leverage effect. Why? Because we have already seen that our model has a leverage effect because C4, meaning that this one, right, this one, C4 is negative and significant. Now we want to check whether this EGARCH model is good or bad, from the statistical point of view, whether this model is good or bad, meaning that diagnostic checking, right? And here we have only estimated the EGARCH model using normal distribution. Okay, so now we are doing diagnostic checking, meaning that there is no serial correlation that is desirable, there is no arch effect that is desirable, and the residuals are normally distributed, that is also desirable. Okay, now we check one by one. Okay, I go to view, then I go to residual diagnostic. Okay, first I check whether there is a serial correlation or not. So I choose the second one, parallelogram squared residual, that I choose, right, second one. And suppose here I choose 36 lag, then okay. So here is the result, the Q statistics, right, and corresponding p value, probability value, and you can see all the p value is more than 5%, right? All the p value is more than 5%. So, and what is our null hypothesis? Null hypothesis is there is no serial correlations, right? That is the null hypothesis, and our p-value is more than 5%, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that there is no serial correlation. So we are happy about this model. Okay. Then we can do the second testing, whether this model has arch effect or not. Okay, I go to view, then residual diagnostic, then arch LM test. I click here, and it is the arch model, right? Already it is here. Then I click OK. Okay, it is the arch test, right? Arch test, observed R square, and the probability value is here, right? Okay, and what is our null hypothesis? Null hypothesis is there is no arch effect, and that is desirable. And here you can see the arch result and the p-value. P-value is 78.35%. 78.35%, which is more than 5%. So we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that there is no arch effect in our model. So we are happy about this model because there is no arch effect, meaning that our EGARCH model has no serial correlation and has no arch effect. Okay, then finally what I do, we check whether our model has normally distributed or not, meaning that whether the residual is normally distributed or not. That we check now. Okay, so I go to view, I go to residual diagnostic, histogram. Okay, and here is the results. You can see Jarkabera statistics and corresponding p-value. So here, what is the null hypothesis? The null hypothesis is the residuals are normally distributed. And what is the alternative hypothesis? Residuals are not normally distributed. That is the alternative hypothesis. And here our p-value is less than 5%, right? Here the p-value is very small, meaning that we can reject null hypothesis and accept alternative hypothesis, meaning that residuals are not normal, and that is not desirable. So that is the only problem of this model, that residuals are not normally distributed. And so that is the only weakness. But many say that although the residuals are not normally distributed, but still we can accept the model. We can still accept the model. So we can accept this model. Okay, but finally, I want to say one thing. That is in this model, our variable that was BSR, I assumed that this BSR has no unit root, right? That I assumed initially, that it has no unit root, meaning that I assume that BSR is a stationary data. Okay, that we assumed without checking. Because the data must be stationary to run EGARCH model. But I did not check here. I just assumed that BSR, the variable that we are using, is a stationary. Then I applied my EGARCH model to check whether there is a leverage effect or not. And yes, we found a leverage effect. Thank you very much for being with me for a while.